This Zoom session is being brought to you by the Fractal Horizon, one of my favorites. All right, here we go. Well, today we'll be doing 1.7 and 1.8. 1.7 is about solving linear inequalities, and 1.8 is about solving absolute value equations and inequalities. Okay. Linear inequality, well, it looks like one of these. Ax plus b is less than c or greater than c, or less than or equal to c, or greater than or equal to c. For a, b, and c constant, specify what x makes that true. Okay, so these are inequalities rather than equations. A less than sign, well, it refers to everything x is less than a. The graph of is everything to the left of a looking like this. We have what are called called interval notation, minus infinity to a. That denotes this half line, this inequality. X greater than a, its graph doesn't include a, but does include everything to the right of a, as this graph indicates. It's denoted by this interval notation, parent a to plus infinity n parent. Okay, now these are half lines, and they don't include the endpoints, so they're called open half lines. Then there's x less than or equal to a, which includes everything to the left of a, and x greater than or equal to a, which includes a and everything to the right of it. This x less than or equal to a is denoted by this interval notation, round bracket minus infinity to a square bracket. Square bracket indicates that we include the endpoint. Here, x greater than or equal to a is denoted by the interval notation square bracket a to positive infinity round bracket. Square brackets for when we include the endpoints. We never include a square bracket for plus and minus infinity because we don't include them. It grows towards it but never reaches it. These half lines, which include the endpoints, are called closed half lines. Okay. Now, all right, so given a linear inequality, you solve it by transforming it into a half line. I would do it by the equivalent of algebraic laws like those for equations. A little different. If you have a less than b, then you can add and subtract c to both sides, and it stays the same inequality. A less than b means a plus c, b is less than b plus c, and a minus c is less than b minus c. Same if you have a greater than sign or a less than equal sign or a greater than equal sign. If a is less than b and c is positive, greater than 0, then a times c is less than b times c, a over c is less than b over c. So if you multiply by a positive and divide by a positive, that preserves order. This works for less than, and also works for greater than, less than or equal, greater than or equal. Now here's a little more complicated. If a is less than b and c is negative, then ac is greater than bc, and a over c is greater than b over c. So you multiply by a negative and divide by a negative, that reverses the order. Less than becomes greater than. Now, if we had a greater than, it would become a less than or equal, it would become a greater than or equal. A greater than or equal sign would become a less than or equal sign. So this is almost like transpositions, except that multiplying and dividing by a negative number reverses order. Okay, so for example, let's solve and graph 2x minus 7 is greater than or equal to negative 29. Okay, first thing to do is we add 7 to both sides. That way it cancels on the left, and on the right you get negative 27 plus 9. So 2x is greater than or equal to negative 22. All right, now we divide both sides by 2. That's dividing by a positive number, so the inequality sign stays the same. We get on the left x, and on the right negative 22 over 2. So in other words, x is greater than or equal to negative 11. It's the inequality. Its graph is this half line, starting including the negative 11 and everything to the right of it. The interval notation is square bracket negative 11 to positive infinity round bracket. Here's the solution and graph of the inequality. We have t plus 1 minus 3t is greater than or equal to t minus 20. Okay, we'll subtract 1 from both sides to move this to the right. We'll subtract t from both sides to move this t to the left. That'll keep the inequality in the same direction. And you get on the left t minus 3t minus t, on the right minus 20 minus 1. Bit of simplification, you get negative 3t is greater than or equal to negative 21. All right, we divide both sides by negative 3. That cancels the negative 3 here. This is negative 21 over 3. And because we're divided by a negative number, that reverses the inequality from greater than or equal to less than or equal. T is less than or equal to -21/-3. So T is less than or equal to 7. So this is a half line including 7 and everything to the left of it, as in this graph, denoted by round bracket minus infinity to 7 square bracket. So this is the solution of this. Here we have 4 less than or equal to 9/10 x plus 1. Up here, we'll subtract this 1 from both sides. That'll keep the inequality the same. So you get 4 minus 1 is less than or equal to 9/10 of x. So 3 is less than or equal to 9/10 of x. Now, all right, we isolate x by multiplying both sides by the reciprocal of 9/10. That's 10/9. Now, that's positive numbers, so the inequality sign stays the same, a less than or equal. So you get 10/9 times 3 is less than or equal to x. That simplifies to 10/3 is less than or equal to x. That's a half line, including 10/3 and everything to the right of it. Denoted square bracket 10/3 to positive infinity round bracket. So here's a solution of this. Now we have compound inequalities. Be something like this: a less than x less than b. It's a double inequality. It means that a is less than equal to a is less than x and x is less than b. So this can be thought of as an intersection of two half lines: the a less than x half line, the a less than x half line, and the x less than b half line. They intersect to this, an interval. In this case, an open interval, because we do not include the endpoints. Now, they also include what I call a punctuated line: x less than a or b less than x. Everything to the left of a or to the right of b. It's the union of two open half lines. Now, okay, there are 4 kinds of intervals: a less than x less than b, not including either endpoint. It's called an open interval. A less than or equal to x less than or equal to b. It includes both endpoints. It's called a closed interval. A less than x less than or equal to b. It excludes a but includes b. A less than or equal to x less than b. It includes a, excludes b. These are called half open intervals. We denote them by these intervals: round bracket a to b round bracket when we include neither endpoint, square bracket a to b square bracket if we include both endpoints for a closed interval, round bracket a to b square bracket when you exclude a and include b for a half open interval, square bracket a to b and round bracket where we include a and exclude b again for a half open interval. Okay, and we'll solve compound inequalities by turning them into intervals. So for example, 4 less than or equal to x plus 3 is less than or equal to 7. All right, we want to isolate x between two things, a something x something b. So what we'll do is we'll subtract 3 from all 3 parts all at once. So 4 minus 3 less than or equal to x less than or equal to 7 minus 3. Because we're subtracting, that will keep the inequality in the same direction. All right, after a bit of simplifying, 1 less than or equal to x less than or equal to 4 is the compound inequality. It includes 1 and 4 on the points in between, a closed interval. It's denoted by square bracket 1 to 4 square bracket. And here we have a union of two half lines. Solving graph 3x plus 2 is less than 8 or 2x minus 3 is greater than 11. Okay, for this one, first we'll subtract 2 from both sides. 3x is less than 8 minus 2, or 3x is less than 6. Then we divide both sides by 3, get x less than 2. The less than sign stays the same because we're dividing by a positive number. X less than 2, or, and then from here, 2x minus 3 is greater than 11. Add 3 to both sides. 2x is greater than 11 plus 3. 2x is greater than 14. Divide by positive 2. And that keeps the inequality the same. And we get x greater than 7. So x is less than 2 or x is greater than 7. The graph is these two half lines. We denote that in interval notation by the interval minus infinity to 2, this one, union the intervals, the half line 7 to infinity, this one. We denote union by this u. All right. Now, we also have nonlinear inequalities, which can be solved by sign graphs. For example, the idea is we'll graph the sign of an expression and see when it's positive and when it's negative. For example, x plus 2 times x minus 3 is greater than 0. Now this goes from minus to plus at negative 2. This goes from minus to plus at positive 3. A sign graph will look like this. Draw a line. Will indicate that at negative 2 and at 3, this expression is 0 here and here. At bigger than 3, you have plus times plus, which is plus. Between negative 2 and 3, you'll get plus times minus, which is minus. Below negative 2, you get minus times minus, which is plus. So this expression goes from plus through 0 to minus through 0 to plus, kind of a U shape. Now, let's see. When is it bigger than 0? Yes, here. Not here, not here, not here, yes, here. So it is greater than 0 at less than 2 and at greater than 3. So that's the graph of this inequality. It's written as an inequality. It's x less than negative 2 or x or 3 is less than x. And as interval notation, it's minus infinity to minus 2, union 3 to infinity. This is the solution of this. Here's another one. X plus 2 times x minus 1 times x minus 3 is less than or equal to 0. So we draw a sign graph this way. We draw a line, indicate negative 2, 1, and 3, which is where these turn to 0. Okay. And when x is negative 2, it's 0. When x is negative 1, it's 0. When x is positive 3, it's 0. Above 3, these three factors are all positive. Plus times plus times plus is plus. When you pass 3, but not the other two, then this is negative and these are plus. Plus times minus is minus. When you pass below 1, but still above negative 2, then this is positive, this is negative, and this is negative. Plus times minus is plus. And below negative 2, all three of these are negative, and negative times negative is minus. Now, okay, we want to know, when is that expression less than or equal to 0? Here it's less than 0, check. At negative 2, it's 0, check. Between negative 2 and 1, it's positive x. At 1, it's 0, check. Between 1 and 3, it's negative, check. At 3, it's 0, check. Above 3, it's positive x. So this inequality is true here, 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 and here. On this half, and this closed interval, sorry, in this closed half line, and also this closed interval. So there's the graph of this inequality. You can write that as x less than or equal to negative 2, or 1 less than or equal to x less than or equal to 3. You can also denote that by the interval in notation, round bracket minus infinity to minus 2 square bracket, union square bracket 1 to 3, sorry, 1 to 3 square bracket. Now, this is a little more complicated. X minus 2 squared times x minus 3 times x minus 1 is less than 0. We have a second power here, which tends to make the graph kind of go like to skim the y-axis, not go through it. That's a double root. All right, so let's see. The sign graph, well, let's see. X plus 1 is 0. Is 0 at negative 1, so we put a 0 at negative 1. At 2, this factor is 0. At 3, this factor is 0. So you have zeros here and here and here. Above 3, all these are positive, so you get plus squared times plus is plus. Below 3, but above the other two, you get plus squared times plus, which is minus. Below 2, but above negative 1, get this is negative squared times plus. Oh, the negative squares away, the negative times negative squares away. Negative times plus makes negative. So this is negative to negative. Doesn't go through 0, just skims it. And below negative 1, well, negative times negative, negative squared times negative gets you plus. So when is it strictly less than 0? Not here where it's positive. Not here where it's 0. Yes, here between negative 1 and 2. Not at 2 where it's 0. Yes, between 2 and 3 where it's negative. Not at 3 where it's 0. not above 3 where it's positive. So if you look where we check off, its graph looks like this graph here. -1 to 3, excluding -1, +3, and also +2. This graph is denoted by these inequalities: -1 less than x less than 2, or 2 less than x less than 3. You denote that by this interval notation: round bracket -1 to 2, round bracket, union, round bracket, 2 to 3, round bracket. Now we have an even nastier one. X minus 3 over x plus 1 is greater than or equal to 0. Okay, we have a division. So sometimes we'll get an -1, we'll get an infinity rather than a mere 0. All right, so here we go. Round at 3, it's 0. At -1, it's infinity. Above 3, plus over plus makes plus. Below 3 and above -1, it's minus over plus, which is minus. And -1, it's infinity, and below -1, it's minus over minus, which is plus. Where is it greater than or equal to 0? Well, yes, here below -1. Not here at -1 because that's infinity. Not here between -1 and 3. Yes, here at 3. Yes, here above 3. So the graph is everything to the left of -1, but not including it. Everything to the right of and including 3. So x less than -1 or 3 less than or equal to x. Or we'll denote that by -1, that's a negative infinity to -1, round bracket, union, square bracket, 3 to positive infinity. Round bracket. Now here we have it. Here we have it something that's not written in the form of less than or equal to 0 or greater than or equal to 0. It's 4 over x less than or equal to x, and we don't have a 0 in this expression, but we need one to draw the sine graph properly. So first, let's subtract x from both sides. 4 over x minus x is less than 0. Rewrite that as 4 minus x squared over x is less than or equal to 0. 4 minus x squared is 2 squared minus x squared, which factors into 2 minus x times 2 plus x. So this inequality is equivalent to 2 minus x times 2 plus x over x, less than or equal to 0. Okay, great. Now, all right, at 0, it's infinity. At plus and minus 2, it's 0. Above 2, well, watch out. This is a 2 minus x rather than x minus 2. So it increases as x, it decreases as x increases. So it's negative above 2. This is positive. This is positive. Negative plus over plus is negative. As we cross through 2, this factor goes from negative to positive. So you get plus plus over plus, which is plus. When you pass through 0, this goes to negative. So plus plus over minus is minus. When we pass through -2, this factor goes to negative. So you get plus minus over minus, which is plus. When is it less than or equal to 0? Well, not here where it's positive. Yes, here where it's 0. Not yes here where it's negative. Not here where it's infinity. Not here where it's positive. Yes here where it's 0, and yes here where it's positive. So it will include -2, this interval, but not 0. So this half open interval. Union, include 2, and then everything to the right of it is this closed half line. So that's the graph. The expression will be, the brackets will be bracket -2 to 0, round bracket, union bracket, 2 to infinity, round bracket. -2 less than or equal to x less than 0, or 2 less than or equal to x. Now here things are getting really gnarly. X plus 2 over x minus 3 minus x minus 1 over x minus 2. Now if this were an equality, we transpose the denominators and solve from there. But here the problem is that these denominators may be negative, and they may therefore flip this sign around. So we don't do that. All you can really trust is adding and subtracting. So you can subtract it. So we subtract x minus 1 over x minus 2 to both sides. So this transposes this to the left, and you get that. Then we combine fractions and work on churn here to here to here to here. Finally, we get this. -2x minus 1 over x plus 3 times x minus 2 is less than 0. Okay, great. Well, all right. These go to 0 and the fraction goes to infinity at 2 and at -3. At 2 it's infinity, and -3 it's infinity. This flips through 0 when x equals -1/2. So put a 0 at -1/2. Above 2, because of the minus, will be a minus above 2. So minus over plus plus is minus. Go through 2. The second factor here flips from plus to minus. So you get minus over plus minus, which is plus. Flip through when you go through -1/2, this changes from minus to plus. So you get plus over plus minus is minus. At -3 through -3, this flips sign. So from here to here, you get plus over minus minus, which is plus. When is it strictly less than 0? Not here where it's positive, not here where it's infinity. Yes, here where it's negative. Yes, here where it's 0. Not here where it's positive. Not here where it's infinite. Yes, here where it's positive. So it'll be going by the graph, would be this graph here. This half open interval, excluding 3, but including -1/2. This half open line here, which is everything to the right of 2. So we denote this graph by this interval and these inequalities. Round bracket -3 to -1/2 square bracket union round bracket to an infinity round bracket. Or in other words, -3 less than x less than or equal to -1/2 or 2 less than x.